Good morning. We'll be starting here in just a minute or two. Um, the moment I'm on my own, the internet went down at Amanda's place, but we'll get started at the top of the hour. We'll make it work. Okay, we'll give folks about 30 seconds to finish logging in, and then we'll go ahead and get started. And if you're wondering about the shadow at the bottom, it's my coffee mug. Got to have priorities, you know. Here, we'll move it so it's not so obvious. Yeah, still obvious. Oh well. Okay, good morning. We'll go ahead and get ourselves started. My name is David Orr. I'm the director here with the Cornell Local Roads program. We're your New York State LTAP Center, and welcome to the third of our summer series of foundational webinars. Uh, this week and next week's webinars are independent. They're each, separate on their own, but there are a lot of overlap. So reset them a little bit so that take advantage of that fact. So this week is surface and subsurface drainage, and the next week we're going to be talking specifically about the gravel and base in a lot more detail than we're going to be talking about in our hour together today. So both of these sessions are worth a PDH, so we'll talk about that in a minute as well. Now, if you haven't been on one of these webinars before, audio settings is on the lower left. We do ask you to open up your chat pod and your Q&A pod. The chat pod is disabled for you to put things in, but that's where you can put we can put stuff to you. That's a link to the handout, a link to the polls. You have to type all those things in, and we'll repost that here in a couple of minutes after we make sure folks are in. I will ask you to raise your hand a few times during the course of our hour together. So we'll go from there. And as I said, this is worth one professional development hour for continuing education for engineers here in New York State. Technically, only the person is registered, and it is technically a course, but that's not as critical as it used to be. They changed the rules a couple of years ago. If you're from outside New York, we're going to find that out in just a second. You'll need to check and see if your LTAP center knows whether this is worthy of a PDH in your particular state. So let's do a little welcome and find out who's on the session today. And again, the polls is pollev.com/DavidOrPE. Okay. And again, if you've got any questions, throw them in the Q&A. We'll be using that. Questions that I'll ask or questions that you've got about the video or the audio and things like that. So let's find out, who do you work for? So are you with a town, a county, a city or village, state or federal, tribal, MPO? You work for an authority like the Thruway Authority, you're a consultant, you're a contractor, or you're just working for a living. I might change that. So. So it looks like quite a few of you are consultants. State or federal is actually a pretty high percentage. And we have some town, just a few town, county, and village folks. A good variety, and a few folks working for a living. What is your job? Are you an administrator? Are you the highway superintendent or commissioner? If you're a deputy, please put that down. Are you an engineer, a planner, field crew, supervisor, board member? You do whatever the boss tells you to do, or none of the above. I would ask, if you do choose the none of the above, throw that in the Q&A so I can know what that is. And if you can't access the polls, put your answer in the Q&A as well. Just helps me figure out who's here. So we had someone, for instance, put in that they're a field crew. Actually, they put an E down. So that's cool. I like to see that. Okay. And then how long have you been in your current position? This is always fun when we do this right after the election cycle. We can get a lot of folks who are really, short term. Um, so we have less than 3 months, all the way up to 20 plus years. So quite a variety. That's cool. Okay. That's quite the spread. And then lastly, where are you from? You can actually click on the map and we'll just see where folks are from. This sort of helps me. I'm just trying to get a sense, is this mostly an urban group? Is it rural? What are we dealing with? And we have somebody from Pennsylvania, or at least as far south as they can mark it on the map. Okay. And New Jersey's rep and Ontario. And looks like we even have a Quebecer up there. Okay, our Quebecois. Okay, good. That helps me actually quite a bit. Uh, good, lot of urban, but there are a few rural folks, so we'll talk a little bit about both when it comes to drainage. Now, in terms of drainage, this is a picture that comes from ARTBA, the American Road and Transportation Builders Association. They're one of their publications they put out. It showed what roads looked like about 110, 115 years ago. Three things of note. One, everybody's wearing a hat and a tie, but more importantly, drainage problems were a problem back then as well. And if you don't keep it dry, it's really hard to make roads work. And so that's really the key here is we really want to make sure we take care of the water, whether it's on the surface of the road or the subsurface of the road. And yes, we're essentially covering some of the foundational stuff that goes with our class on drainage that's listed in the handout. And before I forget, actually, let me highlight that for you. There it is. So there's a handout. And again, if you can't download it, let us know. We can always email it to you. It just outlines what we're talking about today, has some good resources that you might want to look at later on, including a link to the workshop manual for our drainage class and list our upcoming training activities as well. But we're trying to maintain roads and streets. And to do that, we got to get rid of the excess water. And that excess water can come in lots of different ways. And worse, it can stay there. And so what we're going to talk about today is hopefully solving that problem. And of course, that water can come in lots of different forms. This happens to be snow, okay? And somebody put in the Q&A, the last picture, this one looks like mud season in Vermont. Yeah, it could be. Could be mud season almost anywhere. The point is, if you got excess water due to precipitation of almost any type, you're going to have problems. So you're trying to get rid of the excess water, okay? When all this snow and ice melts, you got a lot of water to deal with. Or the rain we got. We got some great rain yesterday because it was nice and slow and all that fun stuff. But so we'll go from there. Now, when we have the whole day together, we'll get into a lot more detail. We'll talk about the roadway, and we'll talk about the roadside, and we'll talk about culverts and erosion and ditches. Uh, we have to break these things up with the webinars. We know that the mind can absorb what the can endure, so we typically leave them to 1 hour. So we're going to focus today on the surface water and the subsurface water. How do we get that water out of the roadway if it gets in there, and how do we keep it from getting there in there if we can? Okay? And hopefully by the end of this hour, you haven't totally graduated, but you've at least got a sense of what kind of work we can do to make drainage better. Now, when I say drainage to most people, and I talk about drainage failures, most people think of something like this. This is a typical drainage failure, okay? And so just as an example, let's just have a little fun here. Let's see what y'all come up with for solutions, okay? So see what y'all come up with for solutions here, okay? And while you do that, I'm going to set something up here, see if this technology works today. Okay, rebuild, grading. You might need to do a little bit more than grading in this particular case, I will admit. I think it's a nice thought, but I think there's probably just a little bit more on it than that. Okay. Yep. So, okay. So storm drain stabilization. Yeah. Larger cross culverts. Again, when it comes to drainage issues, the thing to keep in mind is where did the problem start? Okay. In this particular case, if you look carefully, especially if you, and it's, the pen tablet was giving me challenges this morning, but I think we can make this work. If you look down here, you can actually see, and even a little bit here at the beginning, the roadway was incised a little bit. In a lot of gravel roads, this happens. The roadway gets incised, and then when it does flood, the water can't get out of that channel of the roadway. It becomes a stream bed. And that's what happened in this case. So if you don't take care of getting that water off the roadway, this just becomes a river, and you essentially have all that scour that forms. So think not just about rebuilding, but how do you keep that problem from coming back? Let's do one more, and then we'll get into some of the lessons learned, and we'll end with a few solutions to see how we did. Okay, so let me see if this technology works. I'm going to clear the answers, and let's see if this technology worked for us today. Hey, it worked. So it's nice when technology works. What solutions do you have here for this particular roadway? Okay, what do you think happened? Because generally when you think about a solution, remember, you have to figure out what the problem is. In fact, a couple of the examples we'll end with, there's two or more solutions because it depends on what's causing the drainage problem. So what's the solution here? So increase the cross slope, do some grading, maybe more established ditches. Certainly start with some pavement cores, figure out what you've got. Okay, maybe deeper ditches, roadside ditches, everybody's saying. Resurface. Okay. Better porous base. Ooh, there you go. Now we're getting there. A thicker base layer may or may not have helped here. Okay. So we're going to go back to the picture. Now it's hard to tell in the picture, and I apologize for that part of it. That's one of the challenges of doing webinars. Pictures don't always tell you everything. But in this particular case, the ditch is actually deep enough. The ditch goes into the subgrade, the non-road part of the roadway, the native material. So the ditch is actually deep enough. It had been a gravel road for decades, but they chip sealed it, and they had the wrong gravel. And we'll talk more about that. It's not the depth of the ditch. It's not even the cross slope. It really comes down to the materials that were used to build the particular roadway. So we'll come back and we'll talk about that. These are all things that are things we can do. Okay, so we're going to move on past our solutions page, and I'm taking a risk. I know. I got two videos I'm going to show you today. I'm going to take a risk. I'm going to show a video. You may have seen this video when I've done other sessions or in person. This is a video from the U.S. Forest Service. Okay? Watch the two green dots as the trucks go by, and you can actually see the pavement move. Okay? And so this pavement moves because of three things. One, obviously, we've got trucks that are causing it to move. All pavements move under the weight of a truck and a car. But because there's a lot of water and it's a really thin pavement surface, it moves more. And it's that more movement that causes it to fail faster. How could you solve this problem? Well, obviously, take care of the water. Yes, a thicker surface can help, but if you don't take care of the water, it doesn't matter how thick that surface is. So the key is to get rid of the excess water. So we're going to start by looking at the surface of the roadway. You know, if you look at this particular roadway, this had been bladed or dragged to smooth it up, but they probably were going a little fast with the grader. But the more critical problem is it created a flat spot. You absolutely don't want a flat spot in your roadway because that water, the best case scenario in this case is it evaporates, but the more likely is it slowly permeates into the gravel and it saturates it and it makes it soft. So you really want to have a cross slope on your roadway. That's absolutely key. Okay? So if you've got a paved roadway, you want about 1/4 inch per foot. Okay? Which, by the way, is also 2%. Yes, I know, they're not exactly the same, but they're so dang close, don't worry about it. Okay, and that helps get the water off the roadway. If you've got a gravel road, you know, I'll even write the word paved. You'll have to deal with my handwriting and the pen tablet being slow. If you've got a gravel roadway, it needs to be steeper. It was research that was done here back in the 50s, and Typically, if it's a flat stretch of highway, fairly flat, you might need 6% to get a crown. In fact, the crown is more critical in a gravel roadway than it is on a paved one because the surface is not as permeable and can be discharged by all the vehicles going along. And by the way, if you're wondering if you re-put in a culvert or you rebuild a stretch of roadway, what should the cross slope be on the lower layers? Take your upper layer and match. So if it's going to be paved after you're done, put at least 2% in. If it's going to be gravel, put in 6% grades. In other words, do the grading work at the sub-base level or the subgrade level. It's actually cheaper anyway. It's easier than to place the other layers because they're consistent thickness. But make sure they drain all the way out. Now, this particular picture, this is up in the Adirondacks. I took this, it's a couple of decades ago now. But those potholes you see in the front corner are not caused by the quality of the gravel. They're not caused by all the snow and the ice. They're caused by the lack of a cross slope. You really need the cross slope on a roadway. If you don't have that, the water can't get away. Traffic comes along and it creates potholes. And so if you go down a gravel roadway and you notice these big rounded potholes, they're caused by a flat spot. I live on a gravel roadway and they put in some pavement at one end and created a flat spot. And now it's just always potholes. And people who maintain it throw some gravel in, but it goes right back to potholes. But make sure you get a cross slope. Now, if you have a gravel roadway, and let's go ahead and do this. How many of you have a gravel roadway that you deal with on a regular basis? Raise your hand. Go ahead and raise your hand. Go down to the bottom of the screen, raise your hand. Okay. This is linked in the handout, but it's also available online. It's actually a pretty cool video. This comes from our colleagues in the South Dakota LTAP Center. This is the Gravel Road Maintenance Meeting the Challenge. They have a workbook. And then there's also this video that you can find online. Again, it's linked in the handout. And we'll see if it plays today. This one may or may not. I may stop this one after just a minute, but I'll stop the sound for the second, for the sake of argument. But this thing talks about the quality of the gravel, roadway shape. It talks about the fact that you've got to get the water off a roadway, and it's even more critical on a gravel roadway than it is on a paved roadway, but it's true on any roadway that exists. You get a flat spot, and actually it's one thing I don't like about this video. It shows a parabolic surface. You do that with a gravel roadway, that little flat section right with a parabolic section at the middle, it actually creates problems. And yes, as they say, it's actually a safety issue in a lot of ways if you get a flat spot, okay? So if you're interested, download it. You can watch it online at your leisure. It's actually a pretty cool little video. And they like a minimum of 4%, but I found, especially with the glacial tills we have, we want to be a little bit more than that on a flat stretch of highway. Now, here's a case whereby you could have better cross slope, and no, the cross slope's not very good here, but you've also got to have the right material in the gravel itself. The quality of the material here isn't very good, and here's a close-up of the rut there in the lower left corner, and you can see it's got nothing, okay? It's got absolutely nothing going on. There's no rocks of any size. The largest I found when I put my hand in it was about a quarter of an inch, so it's not very good. Now, before we go too far and talk about what makes a good gravel, and again, we're going to do a lot more on this at next week's webinar, but we're talking about the drainage issues right now. You get a roadway, you're rebuilding it, you've milled off all the surface, you've got this exposed material. Okay, let's just make sure we're all on the same page. What do you call that unbound material? And I'm going to leave the poll closed. You can put your answers in, and then I'm going to show them to everybody here in about 30 seconds. So what do you call that material? I want to make sure we're all on the same page. Okay? What do you call that material? Okay, let's go see what everybody came up with. And okay. So the subgrade is the under the roadway, but the material under the pavements, base, subbase, gravel. Yep, okay. Now, sometimes when I've asked this question, people will call it crusher run, They'll call it bank run. They'll call it, there's fill I see in there. I see people putting base in there. The point is, what it is, it's a mixture of materials we bring in that's part of the road structure. Okay? And that's actually a very important part of the road structure because we've got the subgrade, which is the material in the area after we've stripped off the organics. That's what we build the road on. And then we usually have an unbound layer that's either the base or the subbase, which could be a gravel mix, crusher run mix, different materials. And then eventually we'll have bound layers above that. And depending how thick your pavement is, you might have a bound base layer, you might have an unbound base layer. Okay? So keep these things in mind when we talk about drainage. Okay? But whatever you've got, it turns out, again, some of the same research that talked about the gravel cross slope also looked at the quality of the gravel. Gravel is a mixture of particles of different sizes. And it's got gravel-sized particles. These are things that are essentially, pebble-sized and larger. If you want the exact sizes, you can go look at some of the handouts. Things that are smaller than that, down to what you can barely see, we call those sand. They're really pretty good for drainage, though the finer sands can have issues. And then finally, you'll get the things that are smaller than 75 microns or the number 200 sieve. We call those fines or silt and clay. And here's the key. The quality of the material, the better quality material, has less of the silt and the clay. And if we had 2 hours together, we could talk about exactly why. But what it comes down to is the silt and the clay holds on to too much water and it doesn't let the water through fast enough. And then there's a third item called capillarity, which we'll show here in just a couple of minutes. So you don't want much silt and clay. But if you've got a gravel surface, and many of you raised your hands and said you do deal with gravel surfaces, you need that silt and clay to bind the gravel together. It's your binder. It replaces the asphalt in an asphalt-bound roadway or a concrete with a cemented surface. So you need a little silt and clay there, but not so much that it gets soft in the spring. Okay? Now, the exact proportions are in the handout, but essentially you need at least 50% gravel. You want about 25 to 40% sand, and the fines content, no more than 8%. I'll talk about why in a minute and a lot more next week. And really, that's for paved roads. For unpaved roads, you can get away with a little bit more. In fact, you need a little bit more, 8 to 15%. Okay, so just keep this in mind when we talk about the gravel. Okay. Now, if we can get good drainage off to the side and we've got good gravel that drains out well underneath, we can get away with a really relatively thin surface. Okay. Um, the thickness of that asphalt layer doesn't have to be very thick, or a gravel layer on an unpaved road, if you've got good quality drainage. But if you don't, it doesn't matter what you have underneath. Okay. Good structure starts from underneath. And if you have a roadway that looks like this, be careful about just putting an overlay on it or even doing a mill and fill. Make sure what's underneath is strong enough to support the loads that are placed upon it, because we certainly don't want this to fail later on. Now, we can do pavement maintenance, and that's a whole nother webinar and workshop and all that fun stuff. But the thing I want you to realize is think about the water. In this particular case, they did crack sealing and then paved it the next day. Both no-nos, because it's not a good candidate. But notice right here in the upper left corner, I'll circle it for you. That's a water spot. There was water coming out of that particular spot. And literally within a year or two, we started seeing evidence of failure, and it became a pothole again because it all comes back to the water. So let's take care of the water in the roadway, and our roadways will last longer. Okay, so we need a good surface, we need a good roof. Now let's talk a little bit about the side of the roadway. So we have shoulders. Okay, now you may have curbs and gutters, I know that, but in a lot of ways, curbs do similar things to shoulders. But let's just ask, what is the purpose of a shoulder? What's the purpose of a shoulder? Okay, let's see what y'all come up with. There's 4 primary purposes for a shoulder, at least here in New York State. They don't really have the final one in our friends in Florida, don't have one of them. Remove the water. It's an emergency area. It's a safety issue. You know, you want that errant vehicle or that person who's staying on their phone and not paying attention when they run off the road. The shoulder gives them a bit of a safety edge. Yeah. It takes care of the water. It moves it off the roadway down to the side. Okay. Ah, I see a few folks putting in. It stabilizes the pavement. It literally supports the pavement if you've got a compacted shoulder. It helps keep it in. You've all seen cracking on the edge of a roadway where you didn't have good shoulders. That round cracking, that D-shaped cracking or edge cracking is caused by lack of lateral support. Okay. And then of course I see a few folks and over in the Q&A as well, you're going to have snow and ice issues. You want to be able to store some snow. Now, here's a good example of a road that doesn't do any of those four things. The road water can't get off to the side, so it's not helping carry the drainage. While the shoulder is high, if it's not been compacted, it turns out to not actually provide much lateral support. You actually need to compact your shoulder to get that lateral support. Or you got to use a safety edge when you pave it in the first place. Better yet, do both. Um, if you went off this with an errant vehicle, you might actually get launched. It actually may be more dangerous than not having that shoulder there at all. And of course, you know, we could start filling in the cracks here, but you know, it's going to take me a while. And by the way, if it takes you that long to fill in all the cracks, it's probably not a good candidate for crack repairs. Okay. So we really need to get the water off the roadway. We need good shoulders. Okay. Otherwise, we might as well just have some ice skaters at night when it refreezes. Most critical thing in the surface of our roadway and now on the side is to get the water off the roadway. Now, you should use a grader for this. You should put it part of your maintenance activities. A snowplow is not a good tool. That's what happened here, but the snowplow doesn't go out far enough, and so actually created a spot really just where the water can get back into the roadway, and you can actually see not only is the edge of the pavement saturated all up in here, but also, if you look carefully, you'll see that it's starting to already start to crack. And of course, that debris that was thrown out by the plow has to be cleaned up and leads to phone calls and all that fun stuff. So take care of the water. Now, many of you showed that you were from urban areas. So in an urban area, you're probably thinking, well, shoulders don't do similar things, but actually a curb to curbs, actually they do almost exactly the same things. Okay? They provide lateral support. If the curb has been placed properly, it provides lateral support for the pavement. Okay? And it's going to also carry the water. And normally you've got some kind of drainage system, either catch basins in the roadway or side drains to take the water to your storm sewer system that's underneath. Okay? So it's going to do very similar things. And one of the more, it's actually a bit of a safety issue. If you got your curb height set properly, it does provide a little bit of a safety if people are going relatively low speeds, which is why we typically don't use high curbs and high-speed roadways, because you hit that at high speed, it sort of goes reverse from safety and actually makes it more dangerous. Okay. Now, if I had to pick on the surface, that's really critical is to get rid of the water. This is from Jay Olson. He took this picture in Saratoga Springs, and the quote that he has that we read every time we show it is, drainage is critical for roadway design. Ducts are an indicator of poor drainage. I don't think you want ducks living along the side of your roadway, and yet you've all probably got roads that happens. In fact, I hate to say it, this is an old picture at Cornell, about the time I started. And you can see there's not many catch basins. The roadways curbs weren't high enough or properly set. Had all kind of water problems. And the only reason water got in the catch basin there at the bottom, well, that's because it was badly cracked. Now they rebuilt that roadway about 15 years ago now. In fact, you can see this is a picture I took, I think last year. No, a year and a half ago now. Actually, it's a year and a half ago. So they were just starting to build a new lacrosse building over to the left. You can see where they're just getting ready to start that. And you can see they've done some patching and some other work. So this is in the fall. And a lot more catch basins, a lot more. There's some places where they take the water off to the side, they retain the water on site. So really, much better in terms of keeping the water off the roadway, and curbs set a little bit better, okay? Now, let's now start and talk a little bit about why we cared so much about that fines content of those lower layers. Now, this is a gravel road. We want a little bit of those fines, but remember I said there were some characteristics that we don't like with fines? We don't like the fact that it holds water. We don't like the fact that it doesn't let the water through. But there's another item called capillarity, and that is the fact that water, when it gets into that gravel, can actually go up against the force of gravity. Now, we do a longer demo when we do this in the class, but here's a video. So we've got a capillary tube. It's got a reservoir at the bottom, and Nick, who did the video, poured water in the reservoir. There's little holes to let the water in, and you can actually see the water rising up. And after 1 hour, you can see that it's already up a good 6-7 inches above the water table. So if you've got a water table near the surface, you can literally pull water right into your roadway. And after even only a couple of hours, we're talking about 10 inches or so. If you waited all day, the top of this column would be wet. And that's with sand. If you have silt and clay, it's even higher. Okay? And why is this a problem? Well, it has to do with winter. And again, we're going to be brave today. We're going to try more videos than I normally do. This is a freezing cabinet. This is part of a video, and again, available on the web. You can go look at it, Frost Action in Soils. There's a newer version out there too, but that old version works just fine. In fact, the video I'm going to show you is from the old version and the new version, because it's just such a good video, even though it's got old technology in it. Top of the cabinet is below freezing, bottom of the cabinet is above freezing, but there's a source of water, okay? And so what happens is, because there's a source of water, we get essentially water being pulled up by capillarity through the soil. And so we're going to do a time-lapse video here. So every second is, as you'll see in just a second, several hours. You can see it spinning there up the high-tech timing device. Those little black lines you see forming, those are frost lenses. They're literally water being pulled up and freezing as the temperatures come from the top down. And if you look at the scale on the left, it's moving because essentially the sample is picking up as the water gets sucked into it. And so the project, this particular stuff is silt. It started at 19% water content, and the water gets pulled up. The water that's freezing is, yes, there's about 10%, 19% water to start with, but there's additional water being brought up by capillarity through the soil. And as that soil freezes, it picks the roadway up and you get ice lenses. And those ice lenses are hard to stop because the depth of frost can be 2, 3, 4 feet, heck more in parts of the Adirondacks. You get down to the bottom, started with 19%. By the time they got done with this little experiment, it was 55%. Okay, so over a 35% increase in water content, but even worse, the sample height went from 6 inches to 10 inches in height. That's a 4-inch heave, a tremendously bad heaving, okay? So these are things to keep in mind as you're trying to take care of that water. You want to use material that can handle the fact that it's going to freeze. You don't want it to have frost susceptibility, to hold the water. Here's a picture of a lens with 3/4 inch thick ice, and that's pure ice. And that ice is not the water that was already there. It's water that was pulled up by capillarity, okay? Now you could just put up a sign that says frost heaves. That would possibly work, but that's not really the best method to solve the problem. And of course, if the heaving is differential, what you get is a situation where part of the ground moves and other parts don't. And culverts are really notorious for this. So here's a culvert on a state highway, and you can see where they paved it. The culvert did move in the winter, but the ground did. And you can see how much it heaved, and this is in less than 9 months. And all roads are susceptible to this. This is on I think a county road, but it might have been a town road, I'm not sure. But again, middle of the winter, you can see the culvert hasn't moved, but the roadway picked up around it, and you find it with your car because I don't think they paved it with the striped it with the yellow stripes dipping like that. They were probably straight. So let's look back at our little chart. Those where those lines come into play. That line at 8%, that 8% fines content we found is the line where the frost susceptibility starts to come into play. So you want your fines content to be less than 8% to reduce the frost issues that you have to deal with, and it will drain better. In fact, truth be told, if you're on a really thin surfaced roadway, you actually need better gravel than someone with a thick surfaced roadway because the consequences of the excess water will make your problems worse. Okay? Now, if you've got a roadway that looks like this in the spring, it's not a surface problem. Okay? You could overlay this, spend lots of money on an overlay, but you're probably still going to have problems underneath because you've got excess water. It's either trapped in there, coming up via capillarity, could be a springs in the area. You're going down a hill, so it could be that. But don't pour your money into the surface in this case. Think about the quality of the material underneath. Now, good news I have for you, by the way, is in the middle of the winter, when the pavement is frozen, it's as strong as it can possibly be. That's really cool. That's great news, right? We're in good shape. However, the problem is, of course, it thaws a little bit from the bottom, but a lot from the top. Mainly in the middle where the sun hits the black surface on a paved roadway. And of course, we have shoulder material that may be of different quality. And so we get a thawing in the middle. And of course, all that extra water, remember, 18, 19% water to 55%, all that water doesn't have anywhere to go. And so you get a big water bed and a bathtub. Now, sometimes if there's enough pressure from a side hill situation or something like that, the water can actually pop out into the roadway. This is a picture that Jim Markle sent us. So thanks, Jim. I don't know if you're on here today, but thanks for sending the picture. It's one of my favorites because this is literally what's happening. It's the end of spring and water is coming out into the roadway. And that's actually clear water. Those ice lenses are clear. And so the water coming out is actually relatively clear. But of course, that means that pavement is really weak underneath, and you're hoping the asphalt can survive until the drainage occurs and you're back to a more normal condition. Now, if you're in a really soft, swampy area, you might think about putting down fabrics or geocells or other tools to help spread the load out over a really soft subgrade. But again, make sure you understand what these things do for you and don't do for you, and what is the effect of excess water. In this particular case, all those rounded rocks, you can't compact them. And if you can't compact them, traffic will eventually do it, but it just takes a while, and you can get rutting and other kinds of problems. So think about the subsurface water, try to keep it out of the roadway. And if you can't get it out of the roadway, think about subsurface drains and blankets and stuff like that to take it away. And again, if we had 2 hours or actually a whole workshop, we'd have a workshop on this. We could talk about ways to do that. Now, I'm a big fan of fabrics, but again, make sure you're using the right fabric and understand the limitations of the fabrics. Uh, not every fabric works in every single situation. And of course, you don't want a situation where the fabric fails prematurely because now you got to dig it back up. And fresh fabric does not dig up very well. So try to use it judiciously where it's needed. Now, if you've got that excess water in the spring, well, short term at least, you can think about putting in subsurface drains. Long term, I would think about free draining layers. Okay, and again, make sure the base material is good quality. We'll talk a lot more about that next week when we have our webinar on base and gravel materials. But you want to get that water away from the roadway. Reduce the amount of time that water sits there and causes your pavement to be weak. But one of the things we see as we go around New York State is, well, most of our roads are pretty old. They've been around for a long time. And so here we have a picture from, and again, the book I've got from the 1908 Book of Roads from the Department of Public Works from the state of New York describes this as a main east-west highway on Long Island. Back then, it would have either been what today we call the Sunrise Highway or the Jericho Turnpike. they're a little wider than that today. And so, again, look at your roadway, think about it a little bit, and realize that if you've got a roadway that's got, say, 20 feet of pavement, but the original roadway was only 16 feet, you might have only had good material under the 16 feet. But when they widened it by paving wider or chip sealing wider and eventually putting cold mix on it or hot mix on it, the material out here, okay, it's not good material as a base. It might be okay as backup material, but it's trapping water. So all the water can't get out. It's trapped. So even if I put a subsurface drain in here, it doesn't matter. It's not going to drain any water out of this base, or at least it's going to do it very slowly. And so you can have excess water. How do I know that? Well, look at the roadway. The roadway will tell you. A test pit would be great, but if you can't, just look at the roadway. Here's a classic example of this. Here's a roadway that was not bad, probably had pretty good gravel or base material underneath the main road, but the road wasn't that wide. It was wide enough for a couple of buggies and early cars. Didn't need to have that much width, but as we widened it out to handle trucks and farming equipment and industrial equipment, now we've widened that roadway out beyond its structural support. And you cannot put a subsurface drain in here. You spend the money and effort to put a subsurface drain over here on this edge or over on the upper edge because you can see there's standing water there. It's not going to pull any water in. And you're going to spend a lot of money and not fix the problem. You've got to get the water away. You're going to have to reconstruct this. You're probably going to have to, as a minimum, box out these whole areas to fix it right. Okay? Now, we are big fans of drains, as I said. They work. They can intercept the water before it gets to the roadway. So you've got water coming in from the side hill. This is a very common problem. We don't live in a flat state. So you've got water coming in. If there's any capillarity, that water can literally be pulled right up into your roadway. So a ditch actually helps a little bit, but you don't want to make it too deep because of safety issues. So maybe you come in here and you stick a subsurface drain in. Okay? That can keep the water from getting to your roadway. And it'd be nice if you could get to an impervious layer, but I'm a realist. I know that's not always possible because you really probably want to go down only 2 or 3, 4 feet at the most. And of course, you have to have a place to take this water. If your ditch is here and your subsurface drain is down below that, you're going to have to take your subsurface drain. Oh, it erased everything on me. You're going to have to take your subsurface drain across the roadway and out. Actually, it's not that steep. Let's go over here. There we go. So keep that in mind. You've got to be able to get it out. If you have a storm sewer system, because it's a curved area, you actually could feed it into the storm sewer system. You have to have positive drainage to let the water out of the system. And remember, the water that comes out is only the water that would come out via gravity. Now, if you take a sponge and you put it into a bath of water and you pick it up, it holds a lot of water. And the same thing is true with gravel that has too many fines in it. Fines contents of above 8%, guess what? Hold a little bit too much water. And on the surface, they can evaporate. But if they're a base, they can't. And now in the spring, excess water, premature failure. Okay? So these are all things I want you to keep in mind as we're looking at the drainage of a roadway. And when it comes to your subsurface drains, remember, you're putting a subsurface drain typically at the edge of the pavement because we don't want to disturb the asphalt if we have a paved roadway. Okay? If you've got a curb system, say this is a curb here, one of the best times to put in a subsurface drain is actually when you're putting the curbs in. And you can backfill it with sand and actually a little easier to compact in that particular case. The primary thing you're doing with a subsurface drain is you're draining the base. People think you're draining the subgrade. You are to a limited extent, but your primary is to keep that pavement structure dry as you possibly can. And you'll get a little bit of drainage from here, but maybe not as much as you might like. Okay, so keep that in mind on what you're going to have. And yeah, you could put the subsurface drain in the ditch. That would be fine. And of course, you do have to have a positive outlet. The water does have to get away. Normally, I don't recommend going to the bottom of the ditch line. You want to be up 6 to 12 inches above the bottom of the ditch line because over time, you know that ditch may silt in and they can plug up your pipe. And make sure you're using pipes that can handle the exposure to sunlight. That white pipe's doomed. There's a white pipe here, right here. I'll give you a big arrow so you can see it. That's doomed. It will not survive sunlight for more than just a couple of years. It really should be HDP that's been treated, usually with carbon and other chemicals. It turns it black. This is designed to have a little bit more sun exposure. But also in this case, there's no animal guards. And if you don't have animal guards, what the heck? You might as well let's just be honest. Let's just put up a sign for the critters and say, welcome home. This happens to be in a little place on campus here called Wee Stinky Glen. They used to have the cows for the ag school on the upper end of the Wee Stinky Glen. That's how it got its name. And while the cows aren't there anymore, the name stuck. This is the drain around the administration building, and there's a woodchuck that lives there. Might be a groundhog, I'm not sure. I've never gotten close enough to find out. But definitely likes the underdrain because there's no animal guard, and it makes a nice entrance for a home. So make sure you keep that in mind as you move everything forward. Okay? Now, again, we don't have a lot of time together today, but what I want to do, I want to have a little bit of fun. Okay? What I want to do is I want you to start thinking about what we've talked about, and let's do some solutions together. Okay? So I got about 5 problems we're going to solve together over the next 10, 15 minutes. Let's solve these problems, and I apologize because it's photographs, and you can only see so much on a particular photograph. But let's start thinking about solutions, okay? So I'm going to show you the solutions page. You can start putting them in, what you think the solutions are, and I'll come back to that. But what do you think the solution is for this particular stretch of roadway? And you can think short-term and long-term. In fact, I recommend thinking short-term and long-term, because if you only think short-term, you probably don't have enough money. If you think only long-term, there might be some things you can do in the meantime to at least mitigate the problem. So let's see what you came up with for this particular spot. Okay? So regrade the cross slope, regrade the road. Okay? You might need to look long-term at base improvements. Yep. Okay. Somebody says there might be a subface failure patch over in the Q&A. Okay. You might have to box it out. That might be a long-term solution. An underdrain. Yeah, I'm a big fan in side hill situations, looking to see would underdrain help you. Okay. The thing when it comes to drainage problems with roadways, go back, look at the roadway, and think about where's the water coming from. Okay. If you can figure out where the water is coming from and intercept that water before it gets to your roadway, it's really going to help long term. And then ask yourself, why am I seeing cracking? Why am I seeing failure? Okay, so let's look at this particular stretch of roadway. And again, I apologize. It's an old photograph. It was actually taken by our old director, Lynn Irwin, on one of his days coming into work. He lived out in Brooktondale, New York. You can actually see the vehicles are a little bit older. If you look there on the left, that old microbus from things. And so if we look here, and yeah, most of you are catching it. This is a classic side hill situation. You can actually see there's a cut here. The roadway, the original land came in like this. And so what they did is they cut it here to put the roadway in, and they actually had to fill it over here. Okay? I don't have much of a cross slope. I apologize for that. But there actually is a bit of a cross slope here. It's about 2% cross slope. What's happening is the water coming in from the side is causing the material to have too much water. You add that into the fact that fill tends to behave differently when it freezes, and you're getting actually a crack. This crack is not just due to load, doesn't help. It's actually really a lot due to frost issues. This is actually a weather-related cracking phenomenon, even though it's in the wheel path. The ground's moving differentially as it freezes and thaws. So long term, it's going to be expensive, but you might have to come in and figure out a way to improve the base and the sub-base and put almost a new roadway in at some point, and maybe put some kind of fabrics or even geocells to cross over these different differential points. But in any case, the short term, and I've seen you guys already put it in there, come in here and stick a subsurface drain on the uphill side to intercept as much of that flow as possible. You don't really want to make the ditch any deeper. That's just a safety issue, and it's not going to make enough of a difference. A subsurface drain, well maintained, can help you quite a bit. Okay? So let's see what you guys have. Ditch right side. Might be ditch, but again, no, the ditch should only get into the subgrade just 6 inches or so is all. Anything deeper than that, you're not really helping from a drainage standpoint, and you're actually making a safety problem. Okay? And is water entering from the uphill driveway? Yeah, actually, there's a little bit of it. That actually does come in a little bit too steep. Um, if we had longer time, we could talk about putting in a swale or some kind of intercepting drain to keep the water out. That's certainly not helping. And there used to be a dip in that particular location. The state's actually done some good maintenance on that, and that dip isn't there as much as it used to be when I first moved here to Ithaca. Okay, so I'm going to clear all of our solutions. Okay, technology being what technology is. I got a new problem for you. Okay, um, we now have a pothole. Okay, so we got a pothole. Again, I want you to think short term. I don't want you to think long term. And remember, where's the water coming from? Why is there excess water there? Okay? And so let's see what you come up with for solutions. You can start putting your solutions in. We'll come back and look at them in just a sec. Give yourself a 30, 40 seconds. Okay, let's see what you come up with here. Okay. Full depth replacement I see up there in the Q&A. Rebuild, let's put in a under drain, box it out. Full depth pavement repair. Maybe do a pothole patch short term. Fix the drainage. One of the things I will say is if you've got a roadway that's having problems, a perfect time to take a sample is, well, it's got problems. It's been exposed. So take a sample of that material and have it tested, because one test is worth 1,000 expert opinions. Okay? So you need to figure it out. I love this particular picture. I'd actually like a newer version of it, but this one does illustrate a real classic problem. It depends on why there's excess water, on what solution is going to be the best repair in this particular case. Okay? There's two possibilities for excess water in a roadway. Okay? It could be that you're in a side hill situation and you've got water coming in from the side, and what you're seeing is the effect of that water popping out through your nice clean base gravel. Okay? In that particular case, a subsurface drain on the uphill side, okay, and we'll just make the uphill side over here on the right for the sake of argument. You stick a subsurface drain up there, intercept the water, and not all, but a lot of your problems go away because you've intercepted the water. The other possibility is that the base gravel itself has too many fines above the magic number of, someone in the Q&A want to tell me what the magic number is with too much fines for base gravel? Want to tell me the base gravel, too many fines? 8%, very good, yeah. Truth be told, 5% would be even better, but 8%, yeah. In that particular case, the solution is to stabilize or clean up, and we'll talk more about that in next week's webinar, the gravel so it has a fines content below 8%, so it doesn't hold on to too much water during the spring thaw period. Here's the thing. If you thought the problem was a base gravel, you spent all the money, you brought new gravel in, but the real problem is water coming in from the side, guess what? You still got water coming in from the side. You still may have a pothole. If, on the other hand, you thought the problem was, oh, I'll just stick a subsurface drain in, but the real problem was the quality of the gravel, it may not help. So make sure you figure out, why is there excess water? Is it because of water moving under the soil, or is it water that can't get out because it's too dirty? Okay. So I'm going to clear this one more time. I got two more we're going to do here. Boop. Hey, it worked. Okay. This is an easy one. Okay. Let me come down here and look here, make sure I'm where I think I belong. While y'all guys put in your solutions. Ooh, we got three more actually. Ooh, we'll do all three. We got time. Let's do all three. Okay, let's see what y'all came up with for solutions here. Regrade the shoulder, cut the shoulders. Yeah. This is a pretty easy one. Okay. It's actually a pretty good looking gravel road. It's bloody wide. I mean, it's a lot wider than I would like to see. But yeah, that ditch is fine. In fact, you don't see too many ditches that wide. This was actually sent to us by colleagues at the Wisconsin LTAP Center. Um, but yeah, there's no reason to go uh, do much more than cut those shoulders. Get that water off the roadway. That's absolutely key. So that should be a pretty easy one. Sometimes they're pretty easy, but it does mean you need to be thinking about having an inspection plan. Yeah, there is a bit of a parabola shape on that road, but it's holding up okay. So I'm going to clear the responses. Okay. And we're going to go to our next problem. Okay. And again, I want you to start thinking about putting in your solutions. What do you think the problem here is? By the way, I will tell you what was the original proposal, and that was to put an overlay over this. I hope nobody thinks a straight overlay would be a good idea here. You probably got a subbase failure. Yep. Now let's go see what we got here for people clean the ditches, possibly. Okay. Rebuild, it may be too many fines, it might be high water. Yep. It might be a bathtub that needs an underdrain. Bad base. This particular example is one of the reasons we're huge fans of doing test pits, doing something to see what you've actually got underneath here. Okay. So let's go back and look at this together real quick. Turns out the roadway, after they did a test pit, by the way, a good way to do a test pit is start in the middle and work to one side. They did a test pit and they found the old road. There was an old roadway with actually relatively good material, not great, but relatively good material in the middle. Then you get to the shoulder, the outside 4 or 5 feet, a little too dirty. And then the shoulders, really, really bad material. And what happened in this case, the bathtub effect actually went backwards from what you might expect. All the water got into where it was fairly clean, but that meant that it had excess water in the spring and acted like a bathtub. The shoulder on the outside wasn't great, but it was good enough. And so it held the water in the middle, and then the shoulders, of course, made it even worse. And so once that was done, they did a test pit. You throw out the material in the shoulder area. That's just garbage. Use it for fill somewhere. Blend all of the materials together into a huge windrow, lay it back down. That becomes your new base, relatively clean, and then overlay the whole thing. And your ditches, you may or may not even need to make any deeper. But again, think about where the water is coming from and where it's going to. Okay? Okay, I'm going to clear all the answers one last time. And remember, short-term and long-term and economics all come into play. We're going to do one last one, and it's completely unrelated to what we've talked about, but it's just a reminder how wide the sphere is for drainage issues. And I just want you to remind yourself of that. Okay, so what do you think the solution is here for this particular problem? And again, we haven't really talked about it much, but it's a reminder to ourselves that when it comes to road problems, think of the drainage. You're probably going to be in pretty good shape. Guide rails, hydroseed, riprap. Yeah. I, what we've done here is we've created a safety problem. We took a ditch that wasn't that deep, and we've made it so deep that people are starting to think about guide rail. We should not have ditches that need guide rail. And somebody put in the Q&A, we need more right of way. And you can guess what the right of way is here. It's the top of that slope. Yeah. Really didn't actually need to be that deep. It wasn't really improving things. And of course, all this is eroding away. You're losing material at the rate of tons per mile per year. The tree survived, by the way, and eventually they piped this whole thing in. They made a storm sewer system out of it, essentially. Very expensive repair. Um, but just as a reminder, there's lots of other things out there when it comes to drainage. Okay. And I really don't like to see guide rail placed unless it's absolutely critical. Um, we should not have done something that created that problem whatsoever. Now, again, we've covered a bunch of things. Next week, we're going to be doing a lot more when it comes to drainage issues. And by the way, it's a little pretty waterfall near where I live. Um, so this week we did subsurface drainage and surface drainage. Next week we're going to do gravel and basement. We're going to get in a lot more detail about what makes that good gravel and then how to clean that gravel up. And then we have the rest of our summer series all the way until August 18th, where we're finishing with snow and ice. If you got any last questions, we got about 30 seconds before we'll say good day. You can always send us an email. Our main email is clrp@cornell.edu, or send it directly to me at david.orr@cornell.edu, or go to our website, www.nysltap.org. And with that, I don't see anybody with any questions, so I thank you. I thank you, Amanda, in the background for making everything work, and have a great day, everybody. See you next week on our foundational webinars. Bye-bye.